Hello, my dear students. This is your video of NCERT Solutions, chapter number 16, Light. Question number 1 of your chapter is, suppose you are in a dark room. Can you see objects in the room? Can you see objects outside the room? You have to explain this answer. Now, if the room is dark, there is no light. We cannot see the objects in the room because we see the reflection of light falling on the objects. Can you see objects outside the room? Yes, we can see the objects outside the room because there is light. When light falls on the objects, we see the reflection of that light. So here is the answer. In a dark room, we cannot see objects, but we can see objects in the outside of the room. This is because outside the room there is light. When light falls on objects, we see the reflected light and able to see the objects. Without light, in a dark room, we are not able to see. This is your first question. Now next, question number 2. Differentiate between regular and diffused reflection. Does diffused reflection mean the failure of the laws of reflection? Now, what is regular reflection? When the incident ray falls on a smooth surface, it causes regular reflection, whereas diffused reflection occurs when incident ray falls on a irregular surface. Now next part of this question is, does diffused reflection mean the failure of the laws of reflection? No. It does not mean the diffused reflection is not the failure of laws of reflection. Why? Because laws of reflections, they are followed by both the surfaces, but your diffused reflection is related to irregular surface. Okay, that is why we are getting irregular reflections. Now next is question number 3. Mention against each of the following whether regular or diffused reflection will take place when a beam of light strikes. Justify your answer in each case. Polished surface. Now, polished surface, your reflection is regular. Chalk powder. Now, chalk powder has rough surface, so your reflection is diffused. Cardboard surface is again regular smooth surface. You will have again regular reflection. Marble floor with water spread over it, regular reflection because it is a smooth surface. Now mirror, again it is a smooth surface. Again you will have regular reflection. Now piece of paper, this is a rough surface again. So you will have again diffused reflection on rough surface. Next is question number 4. State the laws of reflection. Now what are the laws of reflection? Number 1, the angle of incidence is always equal to the angle of reflection. This is first law. For example, look here. This is the surface of plane mirror. When incident rays strike on this plane mirror, it makes an angle with the normal and then reflected. The angle between the incident ray and normal is known as angle of incidence, and the angle between the reflected ray and normal is known as angle of reflection. So angle of incident is always equal to angle of reflection. This is first law. Now second law is the incident ray the normal ray and the reflected ray they all falls on the same plane. All lie on the same plane. Very important question. Laws of reflection. Now next is question number 5. Describe an activity to show that the incident ray, the reflected ray, and the normal ray at the point of incidence lie in the same plane. Material required for this activity is plane mirror, holder, ray box. Now procedure is what? Fix sheet of white paper a little beyond. Then place a plane mirror strip vertically to the paper using a stand like this. Throw light from a ray box on the mirror. Now, when you fix the sheet of white paper a little beyond, you place a plane mirror like this, vertically to the paper using a stand. Throw light from a ray box. This is a ray box. Throw light from this ray box to this mirror, plane mirror. Look at the reflected ray. Mark the incident ray, normal ray, and reflected ray. Fold the paper. You will see that reflected ray is not seen in the folded portion. Clear? Now, in the second diagram, look, when we bring the folded portion back to its original position like this, the reflected ray of the light is again seen on the page. You can see the reflected ray of the light is again seen on the page. This shows that all these three, what is the conclusion? All these three, incident ray, this one is a normal ray, and a reflected ray, they all lie on the same plane. This is your activity. Next question is, fill in the blanks. Question number 6. A person 1 meter in front of a plane mirror seems to be 2 meter away from his image, because this is the plane mirror. If a person standing here, the distance is 1 meter. And this is the rule of plane mirror, that behind the mirror, say at the same distance, image is formed. This is also 1 meter. So distance between the person and the image is 1 plus 1, it is 2 meter. Now B part. If you touch your dash ear with the right hand in front of the plane mirror, it will be seen in the mirror that your right ear is touched with dash. So if you touch your left ear with the right hand in front of a plane mirror, it will seen in the mirror that your right ear is touched with left hand. This phenomena is also known as a lateral version. Okay. Now C part, the size of the pupil becomes dash when you see in dim light. It becomes larger. Night birds have dash cones than rods in their eyes. Lesser, because cones cells are sensitive to bright light. Now next is question number 7. Angle of incidence is equal to angle of reflection. Always, sometimes, under special conditions, or never. Now look here, angle of incidence is always equal to the angle of reflection. It is always. Next is question number 8. Image formed by a plane mirror is virtual behind the mirror and enlarged, virtual behind the mirror and of the same size as the object. Yes, this is the condition. Virtual image behind the mirror and the size of the image is equal to the size of object. Absolutely right answer, B part. Question number 9. Describe the construction of a kaleidoscope. Very important question. Now, it is a device. Kaleidoscope is a device based on the principle of multiple reflections. Now, it consists of three long and narrow strips of plane mirror inclined at an angle of 60 degree to one another, forming a prism. This is fitted in a tube. One end of this tube is closed by a cardboard disc having a hole at its center. To the other hand or to the other end touching the mirror's plain glass plate is fixed on which broken pieces of colored bangles are placed. This end of the tube is closed by a ground glass plate. In this way, you are getting your kaleidoscope. You can see beautiful patterns through this kaleidoscope. One important feature of this kaleidoscope, once you have seen the pattern, and that pattern never repeats again. The very beautiful activity. You can make your own kaleidoscope. Next question is, draw a labeled sketch of human eye. You can do this question from your NCERT book. You can draw the well-labeled diagram of human eye from your book. Question number 11. Gurmeet wanted to perform activity 16.8 using a laser torch. Her teacher advised her not to do so. Can you explain the basis of the teacher's advice? No, as the basis of teacher advice is that laser light is harmful for eyes. It may damage the lens, the cone cells of eyes, as these cells are sensitive to bright light. So they may damage our eyes. So our teacher advice is very much right, that not to do so, not to use laser torch. It may harm your eyes. Loss of vision can take place. Next question is, explain how you can take care of your eyes. Number 1, always sit straight while reading or writing. Always sit straight. Number 2, if advised, use suitable spectacles. Number 3, wash eyes with clean water frequently, many times a day. Number 4, do not look at sun directly because of bright light. Your cone cells are sensitive to bright light. Number 5, distance between the reading material and eyes should be about 25 centimeter. And number 6, very important, add vitamin A in the diet. These are the 6 important ways through which we can take care of our eyes. Next, question number 13. What is the angle of incidence of a ray if the reflected ray is at an angle of 90 degree to the incident ray? Now here, listen here carefully. What is the angle of incidence of ray? We know angle of incidence is equal to angle of reflected ray. But here the reflected ray is at an angle of 90 degree to the incident ray. Reflected ray is at the angle of 90 degree to the incident ray. It means total angle is 90 degree. Clear? We know angle of incident is equal to angle of reflection, and both are making an angle of 90 degree. As angle of incident is equal to angle of reflection, this is given. Angle of incident plus angle of incidence plus angle of reflection is 90 degree. This is given. We know angle of incidence is equal to angle of reflection. This angle is equal to this angle. So here angle of incidence plus angle of incidence. If both are equal, then we can write angle of reflection as angle of incidence, 90 degree. So 2 angle of incidence is equal to 90 degree. What is the value of angle of incidence? 90 upon 2. It comes out 45 degree. Therefore, angle of incidence is equal to 45 degree. This is your answer. Now next one is, how many images of a candle will be formed if it is placed between two parallel plane mirrors separated by 40 centimeter? Now the two parallel plane mirrors, they are separated at the distance of 40 centimeter. This is very large distance. So how many images a candle will be formed? It can form infinite number of images. Question number 15. Two mirrors meet at right angles. Two mirrors, they are meeting at right angles. A ray of light is incident on one at an angle of 30 degree. This is incident ray. It makes an angle of 30 degree angle as shown in figure 16.19. Draw the reflected ray from the second mirror. Now look here, this is given to you. We know angle of incidence is equal to angle of reflection. So we are making this angle again of 30 degree angle of reflection. This angle of reflection is incident on the second mirror, and it makes an angle of 60 degree with the normal. Again angle of incidence is equal to angle of reflection. So reflected ray makes 60 degree angle with the normal, and with the mirror the angle of reflection is of 30 degree. This is your answer. Now next is question number 16. Bujo stands at A just on the side of a plane mirror. Side of the plane mirror, not in front, side of the plane mirror. Remember this? Figure 16.20. Can he see himself in the mirror? Also, can he see the image of object situated at P, Q and R? Now here, as you know, Bujo is here in the side of plane mirror. So first answer is no, he cannot see himself in the mirror. Now next question is, can he see himself in the mirror? No. Can he see the image of objects situated at P, Q and R? No. He can see the images of P, Q, R. Yes, he can see the images of P and Q because they are on the mirror, but he is not able to see the image of R. So answer is he cannot see himself in the mirror. He can see the image of objects situated at P and Q, but not able to see the image of object situated at R because it is away from the mirror. Next is question number 17. Find out the position of the image of an object situated at A in the plane mirror. First part. Now this is a plane mirror. This is point A. The image of this point A is, this is incident on the surface of plane mirror. Then we are making one normal over here. When this light falls on this place, join these two lines. The image formed is A dash image behind the mirror. Behind the mirror. Now we can obtain the image of object A like this. This is the answer of A part. Now what is B part? Can Paheli at B see this image? Yes, Paheli at B can see this image behind the mirror. C part. Can Bujo at C this image? Yes, Bujo can see the image of A. D part. When Paheli moves from B to C, where does the image of A move? Now we know the image of A will not move as an object is not moving. Okay, clear? So this is your answer number 17. Now, thanks note. Imagination is more important than knowledge. So be imaginative, be happy always. Thank you. Have a nice day.